Hi, so I thought I was gonna do I figured I'd do something a little bit different. I'm gonna go through the weather tomorrow. Let's take a little look at what the Storm Prediction Center has. You can see it's right in my neck of the woods. I live just around Richmond, so this is definitely in my neck of the woods. We got a 5% tornado threat, and to be clear, I haven't looked at any things regarding this besides this outlook. Um, I will kind of break down my thoughts on it. We do have a 45 wind for DC. If that extends any further south, I'm going to be in it. And the hail threat mostly stays off towards towards the west here. You can see we also have a slight risk out here. It's going to be mostly hail threat. So let's go figure out why. So what I'm going to do first is we're going to pull up 18Z HER, and we're going to look at the simulated reflectivity. Um, just first thing, I kind of want to see what the HRRR has. So this is probably around 6 a.m. I think it's less than that. I think it's like 4. No, 8. Is it 8? It might be 8. Whatever. So you can see we kind of, okay, so we have like a Boeing segment. Over here in the west, you kind of have a bit more messy discreteness, and then they kind of congeal. This southern area that sweeps through Tennessee, it looks like a lot of just congealed cells. And then we can kind of see the Boeing segments here that the HRRR is rendering. And we go into here, we have this really, really powerful, look at that, that's a nice Boeing segment. So let's figure out why. Let's go to the NAM, and we're gonna zoom out here. So we'll go CONUS, and let's look at 500 millibars. So you can see upper level flow. Awesome. That's step one. Um, we do have a kind of, it's not the strongest trough in the world. You can see the winds around the base of the trough aren't really all that strong, but there will be some amount of um, divergence here. You can kind of see the spreading of the winds in the upper levels of the atmosphere, which is what you're going to need for storm initiation. Um, I'm sure it's kind of already been talked about a billion times. A billion other people have talked about it, but when you have air that spreads in the upper atmosphere, air from below wants to rise to fill that void. So we get that. We'll jump back up to those 850 millibars in a second. I kind of want to see what's going on the surface here. So we come to the overnight here. We have this low, kind of dual low pressure system here. We got a low pressure um, over, is that high pressure? No, it's a low pressure. That's low pressure, and then there's some low pressure over there. And you can see they kind of, actually this stays around, and it kind of just, this one shifts around the other one up here. This one gradually moves off to the east. This one quickly advances. And you can see right there, we're getting these little dips in the pressure, which is that's pretty significant. I forget why exactly it's significant. Why is that significant? I forgot. Whatever. Let's look at moisture. Dew point temps. You could see we're not having a problem with moisture. It's the summer. Mostly when we have these situations, we do have problems um with this. We can look at the 700 millibar flow. We can see we got a bit stronger over western Tennessee there. I figure mostly once we get the into this kind of pushing forward cold front linear segment that's established. Oh, is that what it is? Oh, I think temperature might actually just be the cold front. The drop temperature might be the cold front. Yeah, I think that's what it is. That's the cold front. My bad. That's the cold front. Okay. We can also probably see if we zoom in here. Yeah, you can see a wind shift here. So we have winds coming out of the west here, and then they kind of move as you get this cold front pushing through, and they shift off to southerly winds coming from the south. So let's look at it. So we looked at 750 millibars a bit. You can see we got a bit of flow there. This trough actually looks a lot stronger. It's a bit stronger. It's not, again, it's not the most impressive thing, but we can definitely see that the NAM is definitely showing some short waves in there, which again, just kind of help bolster storm growth. We can look at the low level jet. This is going to probably be where we get the tornado threat from. With this kind of line segment that we're looking at, we're definitely looking at a linear mode, so we're probably getting QLCS tornadoes. You can see we do have some 850 millibar pickup kind of around here. You can see it's actually more concentrated towards the south. So there's probably a reason why they have the 5% kind of up here. We'll take a look and see if we can see that in soundings. And yeah, let's look at Cape. You can see, yeah, we got quite a bit of Cape. We got a little bit of a hole here, but I don't know. That might just be NAM cool bias. Because you know that's what the NAM does sometimes, just a little bit cooler than it should be. All right. Let's look at bulk shear. This is gonna be storm mode. You can see we got decent bulk shear in here. It's not the most impressive thing in the world, but you can definitely see our cold front was right around in here, kind of pushing this way, and these shear vectors. Are we even on shear? What the fuck? I wanted shear, you poor. Do we have shear? I mean, these should be. Are these shear vectors? I don't fucking know. I think they're shear vectors. If they're shear vectors, it would make a lot of sense. They're shear vectors. Because look how parallel those are. So yeah, the storm mode is absolutely going to be a linear mode. And we can also kind of, I bet we could see that with how fast this cold front moves. Or low pressure even moves. So here's this low pressure. He's probably like around here. Yeah, it's moving pretty fast. And look at that cold front. Kind of draped through here. Right here. And then it just, yeah, with each hour, or with each 3 hours, it's not moving all that fast, but it's moving at a somewhat decent rate. So we'll go 21Z, and let's actually hold on. Let's look. Let's look. So if we go, can I find satellite? If we look at water vapor, I bet we could see what's going on here. Obviously, that's mosaic, visible, upper level water vapor. You can kind of see, yeah, there's your trough. Yeah, kind of got the same thing here. Yeah. Obviously, these are kind of today's storms. I imagine it's going to be something back here. I'm not actually, hold on, let's see. I'm not actually certain on that. What that is. I think it is just like a tiny shortwave that's in here. And then this, which is kind of currently, it's really not all that impressive up in like centered around Iowa. It really digs down hard. Yeah. Okay, cool. So let's take some soundings. I want to get before this cold front moves through. And we'll take a few. So we'll go 21Z. We're going to take one around Richmond. And we're going to take one up in DC. And we'll also, where else did they highlight? They've highlighted like up near Pittsburgh and Baltimore, like up here. I mean, I guess, but this will be kind of the triple point. We can kind of pull a sounding from mid-Pennsylvania. So let's look at the Richmond sounding. So we can see here, pretty decent sounding. Got definitely enough cape. Mid-level cape is around 2200. That is way more than enough. Weird kind of dry air around 500 millibars, which is kind of strange. It doesn't really moisten up all that much, but it gets relatively more saturated than it would be otherwise. Um, you can see kind of pretty deep moist layer here. It goes about up to 850. It's not as deep as you'd want to see it, um, but it's okay. You can see the lift condensation level is pretty low. It's just around 1 kilometer, which is pretty good. What else we got on here? Like a hodograph. You can see it's not going to be particularly tornadic. We don't have the really strong, like low level shear that we're looking for, at least in this sounding, for tornadoes. You can see though it is pretty long, relatively anyway. It's not all that long, but it is decently long. So we can see what's our bulk shear. Yeah, so like 4654. It is going to be somewhat organized. We do have some high helicity values here. 3 kilometer is going to be around 159, which is like just around what we want to see for tornadoes. So we could definitely see some tornadoes come out of this system, though I imagine it's not going to be the most likely thing. Again, the SRH below 1 kilometer is really not that great. Let's look at 3 Cape is only around 67, so you also don't have the. I mean, it's a decent 3 Cape value. I don't think it would be problematic for, you know, for tornadoes. I think they could very well form in that environment. But yeah, with this not very strong looking hodograph here, I don't think it's going to be very likely. But we'll just have to see. It's going to be a nowcasting thing. It is in the playbook, but I'm not really convinced. We can also look at STP. This is a value that the computer calculates, and you can see we're getting around the EF0 or EF1 range, maybe EF2. I don't really think we're going to get that. I hope we don't, but yeah. So this one is going to be from DC. You can see much of the same going on here. A bit more, honestly, Cape here. I think we had, yeah, it was a bit less, but we have a bit more in this. It's not significantly more. And you can see I mean, the temperature lapse rate here is actually pretty ridiculous. I'm not used to seeing a lapse rate that extreme, I guess, for that section of the atmosphere, which is pretty crazy. And we got a nice moist layer extending up to 850 millibars. You can see our SRH up here, at least in the low levels, is not as good as it was actually in Richmond. And shear is pretty abysmal at 8. But you can see the 6 and 8 kilometer still in the 50s range, which is pretty good. 3 Cape is a lot more present right here. We got a lot more 3 Cape. We got 120, which is almost double what Richmond has. So that low level instability is going to be a lot better. So if we see any rotation in the low levels, that 3 Cape is absolutely going to take advantage. And you can see even in the 3 kilometer range, we do have a pretty solid SRH value of 172, which is significant. I just don't like that it's not in the low values. You're going to have something sustained in order to create supercells, and I don't know if that's going to happen. That's just being honest. So let's move on to Pennsylvania. We can see we're a bit more in. Oh, you can instantly see why this is. You can absolutely instantly see why they would put this as more tornadic. I'll run through it though. You can see we have a lot less Cape actually up here, only 1,300. Still though, it might get the job done. Our 3 Cape only at 88. Still is more than Richmond though. So that's going to be pretty good. You can see the thermodynamic profile here. It's not very impressive. We don't have a big amount of CAPE being stored here. It does kind of stay pretty moist though, as we go up through the atmosphere, which is impressive. I don't actually know what's going on there. I don't know how that will affect storms. Usually, when you have more moist, it means you have a bit more um, you have a bit more like lift and all that. Where's the weather prediction center? I want to see the weather prediction center. Let's look. And let's look for tomorrow. So yeah, you can see, yeah, that makes sense. We have a slight risk for excessive rainfall up here. And that kind of makes sense. The value we're looking for is PW here, which is precipitable water. You can see it's pretty high up here. I imagine if we go even further north, we're going to get more precipitable water. And that probably has to do with the fact that it's staying pretty moist throughout the atmosphere. Now let's go over why this is more tornadic, and it's because of this photograph. Look at that. That's pretty good. That's pretty classic right there in terms of photograph signatures. Look at our SRH. That's 190 in the first kilometer. That's pretty good. You will absolutely get the job done for tornadoes up there. 317 in the first 3 kilometers. It's really good. This profile is it's pretty nasty for tornadoes, at least in the low levels. You probably want to see a bit more stretched out though. That would have a bit more organization. Doesn't look like that's going to necessarily happen, though. I imagine if you're going to be if you're up here where the low pressure system is moving through, I imagine we're going to probably have a bit more of a discrete storm mode, because the cold front isn't going to be moving as fast through that area near that triple point. And I bet we could probably see that if we actually looked at a convective allowing model. Yeah, simulated reflectivity. Yeah, you can kind of see we're a bit more scattered up here. Bit more discrete. Not too much more discrete, but a bit more. So yeah. I guess that's pretty much it. So, in summary, watch this risk. The overnight models might just completely change. I'll read this eventually myself, but yeah, watch this. Watch where these lines end up. Watch where the Storm Prediction Center is watching. And I imagine that everyone will have a pretty windy day tomorrow. Again, the main threat is going to be wind, slight tornado risk up to the north, especially around DC, especially for a lot of West Virginia, which is very unusual. You don't really ever see that. I mean, they don't ever rate tornadoes there anyway. You can't find them. Again, a very slight tornado threat for Richmond. I'd say, you probably want to be a bit more on the lookout for wind in Richmond, especially also in DC and Baltimore, where they have that 45 unhatched. If that goes hatched, we will get a moderate risk. Again, it doesn't really matter. It won't change whatever happens tomorrow. So, and obviously the more populated areas down in the southeast, we'll just get the remnants of what we get. So, probably some wind, not a lot of tornadoes, and hail on the backside as these storms fire up and transition to linear mode. There you go. That's my forecast.